Now we're going to look at the average value of a function and how to find that. So what is the average value of the function? If you look at this, the average value here is the average height. We looked at every height of this curve. We would find the average height of all those. And if we summed all those up and we found that average, we would see that this average is this value in here for this problem on this picture. Think of it as this is maybe some sloshing water in a bathtub. And at an instant of time, you took a photo and you graphed it, the height of the water in the bathtub at that specific time. Then you let things settle down, right? That settled down, you would have the same amount of water that you had when it was splashing up like this. And it would be settled down. It would give us what was in this crisscross place. And then if that happened, we could find the area. And so we're going to use that fact to help us find the area under a curve. So let's just talk about some things about the average value. So sums can be used to approximate average value. So we could have gone back over here and we can do what we were doing before. Oops, turn it. By making rectangles and summing the rectangle to get an average value. In fact, the average value of a function f on an interval AB can be approximated by 1 divided by b minus a times the area of f on that interval AB. So the basic idea, if the average value of f is denoted by c, then the area under f on AB, that would just be the average height, c, times that length, that base of our rectangle, b minus a. So the area of f on AB is equal to the area of the rectangle whose width is b minus a and whose height is c. So if this is the case, that the area of f on AB is equal to the average value times b minus a, then we should be able to find the average value. So the average value c is equal to, well, if we divide both sides by b minus a, this is going to equal the area under f on AB, all divided by b minus a. We're going to see this soon next week when we talk about definite integrals, and we'll be able to find the exact, or we can find that average value. Right now, we just have to use the estimate of that area under the curve by doing what we're doing with the rectangles. So let me pull out an example for us to do. So now we're looking at an example, finding the average value. The directions in our textbook say use a finite sum to estimate the average value of f on the given interval by partitioning the interval into 4 subintervals of equal length and evaluating f at the subinterval, it tells us to use the midpoint. So we're going to have 4 subintervals. So we're going to have 4 rectangles. And we want to find the average value. So if we do this, we need to find out what our base is. And our base of our rectangle is going to equal 2 minus 0, all divided by how many rectangles? 4. And this is equal to 1/2. So if we look at this, we're going to have one at 1/2. We're going to have one at 1. We're going to have one at 1.5 or 1 1/2. And we're going to have one at 2. So because it wants the midpoint, we want to look at what our value is, the midpoint of our interval. So we want to look at what's happening at a quarter, between 1/2 and 1. We're going to look at the height at 3/4. So here at 1 and 1 1/4, 1 3/4. Okay, so our area is going to equal 1/2, which is our base, all of f of 1/4 plus f of 3/4 plus f of, and I'm thinking about this when I'm plugging it into my value for x and then cubing it. Let's rewrite these as improper fractions. So 1 1/4, that would give me 5/4. And 1 3/4, that is 7/4. So we're going to go back and we're going to plug those in wherever we see an x and f of x. So we have 1/2, 1/4 cubed. Well, that's 1/4 cubed is 64. Plus 3/4 cubed. Well, 3 cubed is 27. 4 cubed is 64. 5/4 quantity cubed. 5 cubed is 125. 4 cubed is 64. Plus 7/4 cubed. And I'm not sure what 7 cubed is. It's 343 all over 64. So let's sum up our numerators. Our denominators are the same. So we already have a common denominator. So 1 plus 27 plus 125 plus 343. That gives us 496 all over 64. Okay, but that is just our area. And I'm going to take a second and I'm going to reduce this a little bit. So I know 2, it's an even number. Well, 2 goes into an even number, 496. So that 2 goes into 4 twice. Evenly, 2 goes into 9 4 times with a remainder of 1. So 2 goes into 16 8 times. I noticed that 64 and 248 are both even. So let's see. I believe that they both have 4 in common, at least. So 248 divided by 4 is 62. And 64 divided by 4 is 16. So they have 2 in common, so 31 eighths. but the question asked us to find the average value. And the average value is going to equal the area on the bound, which we just found, 31/8, divided by b minus a. So b minus a is 2 minus 0. So 31/8 times the reciprocal of 2, which is 1/2. So we have 31/16. Okay, so let's just visually look at what that's telling us with a graph. Okay, so right here, we pulled up the graph. We basically were finding the heights of the rectangles at our values. And those heights, and we basically are averaging what your y value is on the interval between 0 and 2. And we got that it was 31/16, which is approximately 1.9375.